So today we're doing a deep dive into a really specific piece of gear.
Right, the QSC DTH1620 and Amplifier.
Exactly. And we've got the technical data sheet right here, but the real mission for this deep dive is, it's all about context.
That's about engineering something for a place you'd never expect.
Yes. We're looking at how you build high-end audio gear that has to survive, well, being strapped inside a roller coaster cart.
And that's a perfect example of what people call invisible technology.
Yeah.
I mean, the documentation itself calls it out for themed entertainment usage and mobile attractions.
Okay, and let's clarify that term mobile, because in this industry, that doesn't just mean you can move it around easily.
No, not at all. It doesn't mean a touring band's setup.
Right.
It means the amplifier itself is physically moving through space and fast. It's bolted into the chassis of a dark ride vehicle.
So it's experiencing G-forces, constant shaking.
Constant vibration, shock for, 12, maybe 16 hours a day, every day.
Which explains the first thing that jumped out at me in the specs, the vibration testing. But the real giveaway for me wasn't that. It was the ports.
Ah, yeah.
It doesn't use standard XLR or speaker posts. It uses Molex connector.
That's the dead giveaway. I mean, if you're an audiophile, you almost never see Molex on the back of an amp.
Right. You see them inside a PC or in car wiring.
Because they lock. A standard audio cable is just held in by friction.
So a good tug and it's out.
Precisely. In a studio, no big deal.
Oh.
But on a dark ride, you hit a sudden drop, the G-force yanks a cable.
And you lose all the audio for that car.
You do, until it gets back to a maintenance bay. Molex has a positive latch, it clicks in. It physically cannot vibrate loose.
That whole reliability factor seems to drive the rest of the numbers too. And this is something we have to talk about because it looks wrong.
The power output, I'm guessing.
It's a 16-channel amp, which is massive.
A lot of channels.
But it's only pushing 20 watts per channel. That sounds really low.
It sounds incredibly underpowered if you're thinking about a concert, absolutely.
Right. I mean, 20 watts barely drives a bookshelf speaker. And we're not trying to fill a room here.
No, you're filling a near-field environment, a tiny one.
You're inside the vehicle.
Exactly. The speakers are probably in the headrest, or under your seat. They're inches away from the rider.
So you don't need raw volume.
You need separation. You need control.
So the 16 channels are for pinpointing the audio.
That's it. A sound designer can put a whisper effect right in your left ear, a rumble directly under the seat, and a whoosh sound past your right side, all at once.
Which needs discrete channels, not just loudspeakers.
Right. And honestly, with a unit this small, it's about the size of a book, heat is a huge problem. Lower wattage means manageable heat in a tiny enclosed space with no airflow.
Okay, that makes sense. That brings us to the last big feature, the name itself. Dante E67.
Audio over IP.
So you run one single Ethernet cable instead of 16 heavy audio cables? That's a clear win.
It is, but the network part is even more critical for maintenance.
Because, like you said, you can't just go and look at the amp.
You can't. It's buried in the fiberglass shell of a dinosaur or a spaceship. This system integrates with an ecosystem called QSYS.
Which is for remote control?
Remote control and monitoring. So a technician sitting in a control booth can see the live temperature and status of every single amp in every single car on the track.
So if Car 4's amp is starting to get too hot,
they know it before it fails. They can flag that car to be pulled from the ride at the next cycle. You can't rely on manual checks when you have that kind of throughput.
Wow. So it's a fascinating balance. It has to be built like a tank to survive the ride.
Brute force durability, yeah.
But it also has to be smart enough to talk on the network and report its own health.
It's the perfect intersection of rugged hardware and delicate smart networking.
So here's a thought to leave you with. The next time you're strapped into a high-tech dark ride and a monster roars right behind your ear as the vehicle shakes, don't just think about the ride. Ask yourself, how much insane engineering did it take just to keep that one speaker wire from falling out during that last drop?
It's always more than you think.
Thanks for listening to this deep dive.